This is the Benchmark 19 mine on the Marine Corps Air-to-Ground Combat Center in 29 Palms, California. The project began when Dr. Pat Brownberry found pallid bats at the site. The Combat Center obtained funding in February of 1997. Work began in October and was finished in late November. The mine follows a geological fault, hence the soil is not very stable. There is an overhang of loose rock at the opening and loose materials that crumble to the touch in the mine. Most visitors at the site are Marines on training missions. There are signs of overnight camping, Sialoom light sticks, and debris throughout the mine. This activity caused all bats to abandon the site. Experts like Bob Curry of the U.S. Fish and Wildlife Service were called on to assess the mine and suggest ways to gate it. One suggestion was to insert a culvert and build a gate in that. This option was thought to be inappropriate for the soil conditions and too costly. Other challenges at the site included ammunition, which had been fired at the mine opening in the past. There were small arms casings, aircraft fuel tanks, and 500-pound practice bombs. This bazooka round was live and was embedded just 5 feet from the opening. The foundation required lots of labor. All the equipment and materials had to be carried up a 30-foot incline. Desert temperatures brought the possibility of heat stress, so liquids and frequent rest periods were necessary. The foundation was begun by excavating an area for the concrete forms. Masks were used to protect against dust, hantavirus, histoplasmosis, and other airborne diseases. The form for the concrete is critical. If the form is not strong enough, the concrete can deform or damage it. Sturdy wood and steel reinforcements were used to add strength to the concrete form. Here is the finished form. Notice the reinforcing bars in the bottom and sides. These will tie the walls to the base, thus making the gate one large concrete block. The forms and earth were moistened just before pouring the concrete. This kept them from absorbing the moisture from the concrete too rapidly. The longer the curing process, the stronger the concrete. The foundation was about 3 feet by 5 feet and 6 inches deep. It required 18 bags of ready-mix concrete and 20 gallons of water. Additional water was needed to clean tools and moisten the concrete forms. No water or utilities were available at this site, and everything had to be trucked in over 7 miles of four-wheel drive roads. Here is the finished foundation. It was covered with plastic to keep it moist and clean, and allowed to cure for 14 hours. The next day, angle brackets were placed on the J-bolts, and holes were drilled for wood screws. Then, a wooden template of the gate was built on the foundation. 1 by 2 furring strips were screwed together to exactly frame the opening. All pieces were labeled so the structure could be reassembled in our shop later. The front and back plates were created by using a ruler and a storyboard. The length and angle of measurements were marked on a piece of cardboard, which was clamped to the wooden cage. These measurements were then transferred to another piece of cardboard. The separate points were connected with lines, and the cardboard was cut out with a saber saw. This produced an exact replica of the mine opening. Each piece of cardboard was marked to aid in reassembly later. As you can see, intricate shapes were easily duplicated with this method. And here are the finished templates. The wooden form was reassembled in our workshop, and the task of duplicating it in steel began. 1/4-inch thick plate was cut to match the cardboard forms, and steel angle replaced the wooden frame. All welding slag was removed by grinding, so a finish could be applied later. All panels were installed in their proper place to check the fit. All angles were double and then triple checked to ensure that they were square. Time spent at this point would be more pleasant than the alternative of trimming at the job site. As you can see, the pieces fit together perfectly. All parts were then numbered with the welder to make reassembly at the mine as easy as possible. The final trip to the mine required 3 additional tons of concrete. Of course, all of it had to be moved by hand. This project required ventilation. Welding and paint fumes are toxic, so plenty of fresh air is needed. Our ventilation system provided about 1,400 cubic feet of fresh air per minute. The vent pipe support structure kept it from becoming a trip hazard and directed the air to the work site. Next, the steel cage was assembled on the foundation. All of the steel had to be carried up the 30-foot incline to the opening. Some of the faceplates weighed more than 100 pounds, so plenty of manpower was needed. Each faceplate was welded to the steel frame. Both sides of each joint were welded to increase the strength and rigidity of the frame.
Kind of noisy in here. Okay.
Concrete was then added to the cavities formed by the faceplates and the mine walls. Each batch of concrete was tamped to remove air pockets. The walls of the cavity were kept wet to ensure a slow cure for the concrete. This, in turn, promoted the strongest possible concrete. In all, almost 6,000 pounds of ready-mix concrete was used. It was all mixed, 3 sacks at a time, in a small electric mixer. As concrete filled a cavity, another steel plate was placed above it. Tabs welded on the plates, back in the shop, provided easy alignment in the mine. Each plate was then clamped, welded, and ground smooth. All personnel wore hard hats, safety glasses, and steel-toed shoes. This should be a part of any mine worker's attire. If OSHA rules apply to your project, all of these safety items are mandatory. The final alignment check was gratifying. The top plates on both sides fit in their respective spaces and were parallel with the cage top to within 1/32 of an inch. The shop work had paid off. The last of the concrete went on top. It assured that vandalism, even on the roof, would be difficult. We found the shovel handle would catch on the worker's helmet at every toss, so for this one operation, he removed his hard hat. The last task was to install the bars. They were welded in place with the BCI recommended spacing. They were welded on both sides to ensure maximum strength. And here is the finished gate. The gray finish is a zinc-rich primer meant to retard corrosion. To allow access for biologists, one of the bars is removable. The security fasteners fit into a recess that can only be tightened and removed with a special key. The fastener screws into a lock nut, which was welded in place back in the shop. The lock nut makes it very difficult to remove the bolt without the special key. There is one last item of interest on this project. The Marines are noted for their tenacity and determination in overcoming obstacles. That's what we pay them to do. So, we included an additional locked compartment. Inside, they will find what they crave most. Recognition for a job well done. A word of caution to any who may be considering doing this kind of work. Working in a mine presents special hazards. The Mine Safety and Health Administration requires training in emergency first aid and mine safety before working underground.